Hello, I'm going to give some initial results comparing first cut, design-based, and model-assisted above-ground biomass estimates at the state and county level for the state of Oregon. Our goal here is to find a way to incorporate above-ground biomass predictions made during phase 1 of this project into an estimator for above-ground biomass density that allows us to reduce estimation bias and produce robust estimates of uncertainty that decision makers can use. We also want to examine the potential for incorporating JEDI LiDAR data to further improve estimates. The figure we are looking at here shows estimates of forest biomass density for Oregon from 2001 to 2016 with associated 95% confidence interval bands. The red band shows the design-based estimate where only the FIA observations are factored into the estimate. The blue band shows the model-assisted estimate where the FIA plots and phase 1 biomass predictions are factored in. The green band shows a model-assisted estimate where FIA plots, phase 1 biomass predictions, and interpolated JEDI LiDAR 95th percentile heights are used to inform estimates. Notice how that, in general, mean above-ground biomass estimates tend to agree across estimators. We also see that at the state level, biomass density seems to be increasing over time. We see that the 95% confidence bands for the red points, the design-based estimates, tend to be wider than the blue bands, the model-assisted estimates. This narrowing of the confidence bands shows how the phase 1 biomass predictions are helping us improve our confidence about how much tree biomass is stored in Oregon forests. We see how the green bands, the estimate incorporating JEDI LiDAR, don't seem to be any narrower than the blue bands. This indicates that the interpolated JEDI heights are not further improving estimates at this point. There are a few reasons for this. First, there is a significant amount of temporal misalignment. The JEDI observations are from 2019. We shouldn't expect 2019 JEDI LiDAR to aid 2001 biomass estimation because of the 18-year time difference between field measurements and the LiDAR collection. This misalignment diminishes as time goes on, but even in 2016, there doesn't seem to be much benefit. Second, many FIA plots are far from JEDI observations, which means most of the information used to fit JEDI and LiDAR assisting models are based on smooth interpolations from nearby JEDI shots rather than actual shots over the plots. In the future, we plan to incorporate additional optical data from Landsat 8 and Sentinel-2 to better inform the JEDI LiDAR interpolator to hopefully better predict JEDI LiDAR over FIA plots. Let's try zooming into the county level now. You'll notice that some counties, like Lincoln County, the design-based and model-assisted estimates are in agreement. And we do see that the addition of the phase 1 biomass predictions helps. The blue lines are shorter than the red lines. But for others, like Douglas County, the design-based and model-assisted estimates disagree considerably. There are a few potential reasons for why this happened. By chance, the randomly sampled FIA plots underrepresent low biomass areas, and the phase 1 AGB product is making up for this and shifting estimates downward based on its survey of biomass predictions. Another potential reason is the relationship between FIA biomass observations and phase 1 biomass predictions is very different from the overall estimated linear relationship used in the model-assisted estimator. I tend to think the latter. The FIA invests substantial effort to ensure their field samples are as representative as possible. Our next approach for estimating biomass at the county level will be to employ a spatially varying coefficient model that will allow model parameter estimates, think regression line intercepts and slopes, to change smoothly across Oregon in response to neighboring FIA observations. I encourage anyone still interested in this effort to come visit me virtually at the AGU Fall Meeting, where I will be presenting the next round of results on this project, where I attempt to employ a spatially varying coefficient model to see how it fares. See you in December.